Cool. So I hope now you've understood the gist now of a list and of a dictionary. List. So let's just go over again. My list equals, remember, square brackets. My dictionary is curly brackets like this. And then remember, with the dictionary, it's the one where you need to remember that you can't just put stuff like a list. It's a key value pair, so things go in pairs. So my dictionary, let's say this is a dictionary of prices of something again. So I can say oranges like that. And then we can put the price of oranges like that. And then we can put the maybe oil again, and then the price of oil. So again, when you're solving problems, guys, in code, you need to get creative with the way you solve them. So you're gonna use lists, we're gonna use dictionaries. In upcoming videos, we'll see the use cases for these things, for loop, while loops, and just other general problems that we might have a use case for these kind of data structures. So one more thing, I just want to tell you guys something about a list. So let's again declare a list, right? My list is, let's have a list of just numbers, right? Of integers, not numbers, that's the correct word. So a list is what we call in Python mutable. So something is either mutable or immutable. A list happens to be mutable. So if something is mutable, like this, mutable, this is the word. If something is mutable, it means that it's subject to change should you want it to change. So what that means is, remember I told you about indexing. My list is my list, nah? That's it. But let's say I want to change this index, right? I want to change this one and maybe make it a 0. I would say my list at index point 0, right? So I'm talking to this first number 1 there, and I'm saying must equal, let's say I want it to equal 45, right? If I run this, it'll run no problem. And then if I print my list, so we see how it looks now. Index point 0, so the first index should now be 45, right? So let's see. So you see it's substituted this one now with the 45, and that's what if something is mutable, it can change if you want to change it. Now there is a data structure that we're going to learn about called a tuple that is immutable, that can't change. So the way you declare it is the way it is forever, for your whole entire program. It will never change. So a list not only is mutable, but it's also ordered. So your list will always look like this. Your list will always look, so let me just run it again and keep it 1, 2, 3, 4, 5. So let's check it now. So your list is ordered. So by that I mean the way you declare it is the way it will always be whenever you need it. So this 8 maybe will never ever be there where the 4 is, or the 4, it will always be ordered like the way it is. It's mutable. And is there anything else that I need to tell you about a list as far as its characteristics? Okay, no, just that it's subject to change and that it's ordered. So that's all you need to know for now. The other thing, remember I told you different data structures have got different behaviors. So a list, my list, there it is. Let's say I want to add onto the end of a list, right? So I want to add the number 9. That's also something very useful, something that you're going to need to do a lot as we move forward. So all these data structures, strings, lists, dictionaries, they all have got sort of functions that are specific to them. Remember I explained to you that it's important that my list, the variable, we know that there's a list in there, because then there's certain things we can do with it that you can't do had this been a string. So let's say I wanted to add the number 9. Turns out that a list has got a function called append. So as we move forward in Python, you'll see that when you want to do things to a variable, depending what the variable is, you just say dot and then the function after. So I want to add the number 9 to a list. So that you do that through the append keyword. It's a function, my list. So you tell us what you want to do with what. So my list is this list, recall, and I want to append something to the end. So the minute you say append, you're adding something to the end. So I want to append the number 9. So append, whatever you put in the bracket, it's going to throw onto the end of your list. Okay, so let's check. So I ran that, no problems. If I print this, I should get 1 through 9 now. And then there it's appended the number 9. Where is 9 on my, let's say I want to index number 9. Remember I told you if you want to index something that's at the end of your list, print my list, square brackets, -1 will always give me the last element. We print this, I will get the number 9. So the number 9 is now a part of my list, right? So every time moving forward now, list is part of 9 is part of our list. So that's the append function. If you want to remove something from a list, I think it's .remove. Let's just check and not remove 9. Let's just see what just happens if you... Okay, so remove takes an argument. So remove is the correct keyword, but it takes an argument. So let's see if you have to give it the index or you have to give it what you actually want to remove. So remember indexes, just to refresh you, this is index 0.0, index 1, 2, 3, 4, 5, 6. Remember computers, we start counting from 0, not from 1. So what I want to see now is remove, do I put the actual number? So let's say I want to remove 9. Let's see what happens. So cool, nothing happens. If I print my list, okay, so 9 is gone. So remove is the keyword we use. You'd actually put what, like, in the list that you want to remove. So you'd obviously have to have knowledge of what's in your list for this one. So let's try remove the number 5. Let's see. 5. Run that, and then there we go. 5 is gone. 1, 2, 3, 4, 6, 7, 8. Let's remove 8 as well. 8, run that, and then 8's gone. Okay, so it's the remove keyword. So you remove your append for a list. For now, I don't think there's anything else that we need to know. Remove append. Slicing. Okay. We would also need to know how to slice. So slicing like this, slicing. Let's say I want to get just a portion of the list, right? I want to get a portion of my list. So I want to get, say, the first 3 elements of my list. Okay, it's similar to indexing. I would do something like this: my list, and then I'd open those square brackets, the ones that index. So remember, if I put index 0.0, I'm sorry about that. So remember, if I put index 0.0 and I print it, okay, sorry. Print my list like that. So index 0.0, right, is number 1. I should get. Goodness, you guys are giving me stage fright. Okay. So I get the first element, right? Index 0.0, first element. You know what I should actually do? Let's make my list. Let's not make it numbers. Let's make it strings so that you can see this, so that I can demonstrate this properly, because numbers might confuse us. So let's say hello. Let's say Eastgate is a mall in South Africa. Let us say paper, right? So this is just a very random list of very random elements. Let's actually put a few more. Let's put a number, right? Let's put a float, right? And then let's put maybe one more. Let's put my name, right? So this is a list with a whole lot of things in it, né? Again, so Python also supports overwriting. So if I now say my list equals this, it used to equal this, it will no longer equal these numbers, it will now equal this, right? So let me get rid of this print statement here, and then let's run this so that this is my new list, right? So again, let's just make sure that everything is going according to plan. So my list like this, great. So I've got this list of a whole lot of different things in it. Now, so index 0.0, index 1, index 2, index 3, index 4, index 5. Starts at 0, doesn't start at 1. Let's check that. Index 0 should say hello, right? Great. I want to grab the last one. Remember, I told you a quick way to do that is index -1. It gives me my name that's there at the end. So let me delete the cell so it stops confusing us. Cool. Now, slicing. Let's say I have a list and I want hello Eastgate paper, and I want to put that into a new list. Right, I need that information for something. I want the first 3 elements of my list. I need it for something. For whatever the task it is I'm trying to solve, whatever I'm trying to do, I want just the first 3 elements of the list. So what you would do, you'd say new list, right? Okay, so the way to do this would be my list, open brackets, right? I want index point 0. Okay, so right now I've taken hello. So I've grabbed hello, né? But I want Eastgate and I want paper. So I need index point 1 and 2, right? So how you do this in Python is you'd say 0, because that's what I want. I want to start there. So I've got hello, and then do this, and then I want up until paper. Now paper is index point 0, 1, 2, 2. So this should make sense, right? So let's print this. Right? So this is how you slice. So let's print this. I want hello, Eastgate, and paper to show up, correct? Okay, let's get rid of this. So I want hello, Eastgate, and paper to show up. See, so we only get hello and Eastgate. Now, Python, I know this is not intuitive what I'm about to explain. If you want paper, which is index point 0, 1, 2, we've put 2 there, but why don't we get paper is the question you ask. That's just how it works. If you want index point 2, you put 3. So it's starting index, ending index, but not including. So if I put 3 here, right, it's going to give me 0. It's going to give me 1. It's going to give me 2. It won't give me this at 3, even though you've put 3 there. So that's just the way it works. That's just the way it operates. So you put the starting index and the index you're going to plus 1. Or if I can explain it in another way, starting index to the index after what you want, but not including. So it won't give you 3. So if I print this, I'm going to get what I want. Hello, Eastgate paper. So let's check. And there we go. I've got my paper. If I wanted to save this to a different variable, my new list equals my list, like that, right? So if I run this, nothing's going to happen because I'm not asking the console to show me anything. Remember, show me means print. Print means show me. This is show me. So show me my new list, like that. So now I should get the desired output. So this is called slicing. It's called slicing. So slicing a list will return a list, right? But if you just want one index, it's going to return it to you as a string or whatever the thing is. So if I just say 0 like this, I just get hello because that's what's at index point 0. So I hope that makes sense for a list. I think we will leave it there. The task I would want to give you guys is make a whole lot of lists, get practice slicing, also with integers. So add and subtract integers. Do that as much as you can. And tomorrow we'll learn about maybe a few more things that are useful to know with the list, and then some of these operations that you can do also with a dictionary. And then when we're done with list and dictionary, we've done integer, we've done string, we've done a float. I think at that point we'll do tuple as well in the next video. So we're gonna do the operations for dictionary, and then a tuple. And then when we're done with dictionary and tuple, I think we can then start solving more complex things. We'll start learning about while loops, for loops, if statements, and we'll start solving real problems. So we just want to get the base. We just want to make sure that we've got a strong foundation, strong base. We're getting there. I think we're going to just have one more of these crash course videos where we introduce all these things, maybe one more also putting everything together, and then from there we'll start solving bigger problems now that we understand things and what they do.